Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 21st, 2025, which was about 2 days ago. The big hook is a guessed then refined picture of inference. Early layers make high-frequency statistical guesses, and deeper layers correct them, with more than 70% of those early high-frequency guesses getting replaced. The paper is titled, "How do LLMs use their depth?" And as we'll see later, the implications for efficiency are quite significant. Beyond that, this paper uses a tuned lens probe across 4 open models to show function words resolve early, first tokens in multi-token facts need the most depth, and choice tasks get finalized only near the end. Alright, the introduction set up guess, then refine, and depth dynamics. Figure 1 illustrates the story across 3 panels, so keep the whole graphic in mind. The left panel depicts frequency-conditioned onset, where early layers float high-frequency guesses that deeper layers refine into contextually correct tokens. The middle panel shows multi-token fact recall, with the first token demanding the greatest depth while later tokens surface sooner. The right panel illustrates option-constrained tasks, in which early layers gather valid choices and later layers resolve the final answer. So Figure 1 set the narrative. Figure 2 quantifies it with stacked bars by token frequency. The plots show early layers lean heavily on top 1 to 10 tokens, which act as statistical guesses, while deeper layers swap in rarer, context-appropriate tokens. In Pythia 6.9b, over 75% at layer 1 are top 1 to 10, dropping to roughly 33% by the end. In Llama 3.8b, the shift is similar, from about 57% to around 30%. So, the previous figure quantified how early layers favor frequent tokens. Figure 3 presents decision flip rates, showing how many early top-ranked guesses get overturned by the final layer. In Pythia 6.9b and Llama 3.8b, about 80% of layer 1, top 1 to 10 guesses change, while rarer bucket guesses flip nearly 100%. Flip rates fall steadily with depth, which signals that early proposals are provisional and later layers consolidate context to finalize choices. So the previous figure highlighted widespread flips in early guesses. Figure 4 examines earliest crossing thresholds, which track when the final token first reaches high rank through depth. The top row groups predictions by part of speech and function words, and punctuation surface far earlier than content words like verbs and nouns. The bottom row turns to fact recall, where the first token of a multi-token answer appears much later than the second and third. Well, Figure 4 highlighted when tokens first reached high rank. Figure 5 tracks mean ranks of option choices through depth. The left panel, MMLU, shows valid choices collapse from huge ranks to the top within the first half. Then late layers keep switching among A, C, and D, which signals active deliberation. The right panel, SST, shows a strong default toward positive that only flips at the end. The zoomed-in insets emphasize this two-step pattern. Collect options early, resolve them late. Well, Figure 5 tracked how option ranks evolved through depth. Table 1 reports the number of prompts used for the multi-token fact analyses, split by model and by token position. The counts rise for later tokens, so in 3 token answers there are far more examples for positions 2 and 3 than for the first token. Llama 3.8b generally has the largest totals, while GPT-2XL is smaller, which signals stronger statistical support for later tokens. Alright, 2 takeaways stand out. Models follow a guess-then-refine routine, where early layers make high-frequency statistical guesses, and later layers inject context. And depth use depends on task complexity, with function words settling early while hard first tokens and final choices need late layers. This guides adaptive exits and interpretability. That is it for the AI Research Roundup. I am Alex. Thanks for listening.